Good morning, students. My name is Pankaj Singh. I am faculty of AKGEC from IT department, and I take the topic of COA. It's a starting topic of Unit 1. What is bus and bus arbitration, right? So before starting all these things, first of all, I will discuss what is bus, how it's work, and what are their uses in a system, and how it's work for a different devices that are connected to a bus. So as you see, bus is a medium that is basically used to connect different number of devices in a machine. Here we represent machine is a computer. In computer we have different components, or we can say different devices that are required to run a machine, like processor, main memory, and IO devices. So we need a medium to connect them. Bus is a medium that provide connections in between, right? Secondly, bus provide a communication path for the transfer of data. As we know that in our machine, data is transferred from one node to another, or we can say from one component to another. To send the data, we follow some set of protocols. So we define protocols in buses, like I read here, a bus protocol is the set of rules that govern the behavior of the various devices connected to the bus, as to when to place information on the bus, when to assert control signal, etc. My mean to say here, in a bus we follow a set of rules in which we send the data from one node to another. Means there are some instructions to devices, also to the connecting nodes, how to receive or how to send. Means the size of data or size of bit is fixed to transfer over the network. They also have a fixed slot of time, means they also get a token to transfer data. We will discuss all these things in detail when we go for the bus arbitration methods. As we say, bus is of different types, or we can say it is grouped in a common bus consists three parts known as data, address, and control. As I said earlier, buses is used to share data from one node to another. So in a common bus, we have three channels individually used for different type of information sharing within a machine. One is data bus, second one is address bus, and third one is control bus. We also can say signal if we go for a specific. So we should know what will be their directions, how it's work, and how it's carry the data from one node to another. I discuss here for data bus. Data bus is a bidirectional bus. Why it is bidirectional? Because number of devices connected over a network share data from one node to another. Hopefully it is clear, because when we share a data from one node to another, data may be sent or received by the connected device over the network in a system. Secondly, address bus. Address bus is a unidirection. Why it is unidirection? It is unidirection because address is generated or selected by the processor where data can be read or write. Okay, because we save information in a memory, so address always selected by processor. It is generated at the end of processor. That's why it is called unidirection. Similarly, another signal, or we can say another bus, that is control bus, that operate all the operations within a machine, or we can say it's control all the functions of sharing information or data between the devices. It work as a, we can say, control unit. As control unit work in a processor as a brain, Similarly, the sharing of information over a network is controlled by the control signal, or we can say control bus. Here we specify about control signal because it is important. It control all the operations, like whether it is a read or write operation, that is defined by the control signal. Secondly, what size data is transferred in term of bit byte, that is also defined or mentioned by the control signal. Third, what will be the timing information to indicate whether the processor and IO devices may place data or receive data from the buses. In another topic, we will discuss in detail synchronous and asynchronous sharing of data, but in brief, I here discuss in synchronous mode, two nodes have a right to share data on a same clock pulse, means each device will take a control for a fixed time, that will discuss in the primitive and non-primitive in operating system, but we will go for that topic in detail in next topic. So here we should know what is synchronous, what is asynchronous. In synchronous, all the nodes are connected with a fixed period of time, means if we have, for example, we have 4 devices over a network. In synchronous mode, means at a same clock pulse, they will receive a same fixed time of bound, for example 10 microsecond to each. At that time, they can receive or send the data over the buses. Either it is complete or it is partial. But in asynchronous method, a device hold the control of bus till their operations related to read or write, whatever they are performing is not completed. That is held by a specific bus, that's known as asynchronous method, that is clock based, or that is not time bound. So hopefully here we have clear two things. What is bus? Bus is a communication medium that carry data from one node to another. Second type of bus is, or we can say type of signals a bus carry. It is of two type: data, address and control. Data carry from one node to another, it is bidirectional. Address and control bus, these are unidirectional, these are operated by a processor. Now come to the next slide. Here we have a detailed architecture of buses. Here we can say how are these devices or these buses connected over a network. Here we can say we have 3 devices or components of a machine like CPU, memory and IO devices. Here we represent 3 different buses or signals in a unique way. Here they are independently represented here. Here we are showing the connections. As we see here, as we see here, data buses have a unidirectional connection with all connected devices over a common bus system, right? Similarly, CPU generate address where we have to read or write operation, whatever will be performed, that is selected by a CPU. For example, we want to read a data on address 3603, that is generated by a CPU and placed on a address bus, that will be read by the memory, and concerned input output will transferred by using input devices. For example, from keyboard we want to enter some information or we want to write some data over a specific address for 3603, and after that, as we discussed earlier, all these operations within a network is controlled by a control bus or control signal. So control bus work as a master, or we can say operator of these instructions that run within a network. it control all these things. There are few parameters along with bus, like bus designing parameters that depend upon bus width, means capacity of bus. I read here, bus width of data, bus determine the bit of data transfer at a time. Bus width of address bus determine maximum memory capacity of the system. So carrying of data capacity is directly dependent on bus width. Like bus width generally range from 16 to 32 bit in general bus connections. But if we want, we can extend. That's specifically depend upon the type of application. If we use a specific applications like in scientific field, or we can say for a specific where more data is shared, so we can extend it up to 64 and so on. But if in case of general machines, we can say laptop, we are generally using of 16 to 32 bit bus system, or we can say bus width. Here we represent the connections or the level of hierarchy, that way different devices are connected. As we know that processor and memory have the same speed, that's why they are connected on a common level. Here their direct connection is shown here, and input output devices have a different speed or different data format. Input device generally keyboard or mouse. For example, if we connect a scanner, barcode scanner, to read a data of any product, as we see in malls or in any commercial shop, so the data format may be differ. So to convert that data format into the machine format, or we can say equivalent to the processor format, we need a proper channel, or we need a slot, we can say hardware slot. So here we connect the processor and memory at a same level and IO devices at a secondary level. It's a connection representation. As we know that in general real life, we know that what is the representation of bus in our real life. As we see in transportation, it is a common shared medium. So likewise, it is used, a bus is a shared communication medium. It uses one set of wires to connect multiple subsystems. So if we using a common bus system to connect all devices, if there is some advantages, maybe there are some disadvantages. So we will discuss here advantage and disadvantages of bus system. Here, as we see, this black connection represent bus. Okay, that consists three signals: data, address, and control, as we discussed in detail in the previous slide. As we seen here, there are different devices are connected, like processor, IO devices, memory, and so on. So what are the advantages? Just like we can easily add a new device on an existing system, like barcode scanner. So it's one of the most important advantage of a common system. We can easily add on a device or component on a common bus system. Second, peripheral can be moved between the computer system that use the same bus standards. They can also share the information from one device to another. And the major factor, if we go for a commerce or commercial side of any object, or any machine, a single set of wire is shared in a multiple way. Means if we use a single medium to share information from one node to another, it's very simple. We will save cost and power consumption of a machine. So it will be cheaper for a end user to use the machine. And apart from that, there may be some disadvantages that is related to the, or we can say what are their advantages here. They can be converted into disadvantages if they exceed beyond the limit. Like, what are the disadvantages? For example, if we connect the number of devices more than the range of a bus capacity. For example, bus have a capacity to connect 10 devices and we connect 20 devices. So what will happen? क्या होगा? They will face a problem of sharing of data in form of bottleneck, and bandwidth of that bus can limited to the maximum throughput. So जो भी डेटा अभी तक शेयर हो रहा था हमारे नेटवर्क के ऊपर, that will be limited, और जो नंबर ऑफ डिवाइसेस हमारे इंक्रीज हुए, they will send more data over a communication medium, so that there will be a bottleneck of their packets over the network. They create traffic jam or bottleneck problem. Hopefully it is clear. If number of devices increase, that means traffic is directly proportional to the connected device. Obviously, if device is connected, they will share or accept or send some data. So that create traffic problem, or we can say a bottleneck problem. Secondly, every device, every physical component and every hardware have a limitation. As we discussed earlier, if a bus have a capacity to connect 10 devices and we connect 20 devices, what will happen? Bus speed and capacity will decrease and it will not capable to share data from one node to another node as prescribed speed or as prescribed bandwidth, right? The maximum bus speed is largely limited by the length of buses and the number of devices on the buses. Here, before going to the next topic, that is bus arbitration, we should know how these devices access the common bus system. There should be some mechanism to use the common bus system, because number of devices connected, who will take the first write over share the data and who will take the second, that is defined or described by the help of mechanism that's known as bus arbitration method, right? For example, device 1, device 2, device 3, device 4 want to share some data over a network, so there should be some set of protocols or some set of rules to access the bus or to accept the data from the bus. That is defined by the method known as bus arbitration. Now we will move to the main topic, bus arbitration. Hopefully advantage and disadvantages is clear. Here, what is bus arbitration? As in slide, I read here definition, then we will go to the discussion part. Bus arbitration refers to the process by which the current bus master access and then leave the control of the buses and pass it to another bus requesting processor unit. The controller that have access to bus at an instance is known as bus master. So, bus master what is bus master, what is bus arbitration, that must be clear before going to their methods. Bus arbitration is generally a process, as we said earlier. In this, we will find out who will take the control of bus and how it will be taken and how it will be handed over to another device. In this, master will have right to access bus. When master hand over the, or we can say leave the control of a bus, how the control is taken by the another component or another device. There is some set of protocols or some set of mechanism that is followed to access or control these things. This is done by the bus arbitration method. And in this bus arbitration method, whole operations or whole controls is accessed by the bus master, or we can say it is a mini processor of a device. Simple. Those devices are connected. They have a control unit, or we can say a master that control their all operations, how to receive data, how to send, how to access. This is done by the bus master. Now we will move to the next slide. So there are two basic approach to apply bus arbitration method over the number of devices. These are centralized bus arbitration method and distributed arbitration method. In centralized arbitration method, a single bus arbitrator means a single device perform the required arbitration operations, like how to hand over the control or how to take the control when a control is leave by the another device over the network. Second one is distributed bus arbitration method. As name defined, in this method all devices participate in the selection of the next bus master. That is basically done by the distributed method, in which next bus is selected by the on behalf of different polling values of the devices connected over the network. So our concern is here centralized bus arbitration method, in which a single device work as a bus arbitrator to access or control the bus over the network. Now we will move to the centralized bus arbitration methods. Here, method of centralized bus arbitration. First, here we discuss there are three methods. Method of centralized bus arbitration. First one is daisy chain arbitration method. Second one is polling or parallel arbitration method. And third one is independent arbitration method. So we are here three methods by which a single device take the control or give the control to another device over the network to access the bus. So first of all, we will discuss daisy chain method, right? As we see over the screen, in daisy chain method, it is one of the simplest and cheapest method where all the bus masters use the same line for making bus request. Like in this method, bus grant signal. Okay, before going to the diagram, we will discuss the terms that are used over network or during a bus arbitration. These are bus request, that is represented by BR, bus grant, that is represented by BG, bus busy that is represented by BB. Okay, these are three signals that propagate over the network by the help of bus arbiter to inform the connecting device about the status of bus in form of bus request, bus grant and bus busy. Sorry. Now I will discuss this in a detailed diagram. So if we have four devices D1, D2, D3 and D4, how they will take the control over the buses? Generally, processor will work as a bus arbiter, or we can say master, right? So I show how these connections are connected over the network. Actual how it's work. There is a common data bus that is unidirectional, as we discussed earlier. Address bus, it is unidirection. Why it is unidirection? Because the address is request or generated by processor. And third one is control bus. Here devices are free to request for a device to access bus to share or send or receive the data. But in this method, the bus grant signal is provided in a series. That's why it is called chain method or daisy chain method. Daisy here name of scientist who suggests this method, right? So I make the connections. First of all, I will connect a device in unidirection method on a data bus. So now what will happen? Now I make a BG signal in series. Now what will happen? For example, device 1 requests to access bus over the network. Means device 1 want to send or receive some data. He first requests for a bus on a bus request line. He will send a request that will go to the arbiter. Arbiter will analyze their identity, identify on type of request, their identity, and allocate signal in a series. That is BG, bus grant. Here there are two drawbacks of this method. In this method, by default, the priority of devices is set high to low. Means the device which is nearby to the arbiter that have highest priority, and the device that is away from the arbiter that have low priority. Means if device 2 and 3 both request at the same time to access the bus, who will take the control of the bus? As simple, in this method, the devices which is nearby to the bus arbiter will take the control of bus. So what happen? If device 2 is requested alone, no problem. But if device 2, 3 and 4 requesting at the same time, so again device 2 will take the control over the buses. So what problem happen? There is a one issue create known as starvation problem, right? And second problem, for example, if device 3 get the right to access the bus and device 2 is failed due to some technical issue, so device 3 will never get the bus grant signal because of failure device 2. Node or device failure. These are two basic drawbacks of this method, and advantage of this method because networking is simple and easy, and all these things in a very defined and because all these things in a static manner, means this device has the highest priority and this device has the lowest. As we know that, for example, we know that processor, memory, IO. So in this method it is fine, but this two drawback is removed in the next method that's known as polling method or parallel arbitration method. What are the advantages of this method? As we see here, advantage, simplicity and scalability. We can easily explain or define how this network work, and scalability, we can easily scale their connections. Second, the user can add more devices anywhere along the chain up to the certain maximum value. As we discussed earlier, each bus or each network have its capacity, how many of devices connect easily over there. So we can easily add new devices according to the max capacity of network. What are the disadvantages? As we discussed on a previous slide, one of the major drawback, because priority is pre-assigned, means in a static manner, we cannot change the priority of devices. Because of that, starvation problem is created. And second one, propagation delay rise in this method, because if number of devices is too much, for example, device 10 requests for bus, it will propagate from device 1 to 2 to 3 and so on. And the third thing, as I discussed earlier in previous slide, failure of any device, that will stop the working of whole system, because bus grant signal allocate in a series. So these three problems, or we can specifically case two problems, static priority assigning and failure of any device, is removed in another method that's known as polling method or parallel arbitration method. What is polling or rotating, or we can say parallel arbitration method? In this method, the controller is used to generate the address for the master, means unique priority, the number of address line required depending on the number of masters connected in the system. The controller generate a sequence of master address. When the requesting master recognize its address, it activate the bus line and begin to use the buses. Generally, in this method, all devices, as same in previous method, they can request for the buses in a parallel mode. But what are the drawback of the previous method? Bus grant is assigned in a series method. If any device is failed, the other device will always in a waiting state to accept the token, or we can say bus grant, how to use or how to access the bus. But this problem is rotated in this method as name define. Polling. What is polling? Polling work as we see in a general elections, the candidate which have max poll, he or she can win. Similarly, the device which have max poll, he or device can take the advantage, use the bus over the network. It is a dynamic method. We can dynamically allocate it, as I discuss in a diagram. As we see, we have some control signals. I mention data bus, bus request line, bus busy line, and it is one of the most important, bus polling line. Here we have D1, D2, D3 and D4. As I discussed earlier, these are devices D1, D2, D3, D4 over a network, or we can say over a buses. Here we have a bidirectional connection over a data bus to share a data. Each device have a right to access the bus or request for a bus. So we have a bus request line. They can send a request to access the bus. These requests go to the bus master, or we can say arbitrator, right? And this one is bus busy line, known as BB, BR. In this method, if bus is not busy, the bus grant signal is also sent in parallel form. That's additional control line, bus grant, that is also in parallel. Right? And this is a important one. Polling line that dynamically change the poll count of the connected devices. For example, by default, it have highest, it have lowest poll count. But if we want to change the polling of device to, for example, we are considering out of 10, we can make it max 10, 8, 5, 2. Which one access? That is easily identify. So if device 10, device 2 and device 3 request to access the bus on a bus request line, so master will allocate bus to which one device? He will first check the poll count of a device. For example, as we mentioned, D2 have a max poll count 10 and D3 has a 8. So who will take the right over the network to access the bus? As usual, we know that have max poll count. So D2 will acquire the bus to send or receive the data. In this method, the problem of sharing, failing of node starvation is removed, because we will receive the bus grant signal in parallel. That is BG, BR, and it is data sharing node. And I mentioned from green node, if we want to change the priority of any device, we can change by the help of processor or master that have right to dynamically change the priority of any device. We can again change if required, make it 2, make it 10, make it 8. So that is parallel arbitration method, in which both problem is sought out. One is starvation. If a device has a max pole, like D3 now has the max pole, he can access the bus. Either D2 or D1 is requesting for the bus because he have the max pole count. Similarly, the node failure problem is removed out by the help of bus granting signal in parallel. In previous method, bus grant signal in series. If any device is fail, the another device will not receive till the correction or making the technical fault is corrected. Right? Now the third method is, there are some advantages. This method does not favor any particular devices and processor, but in daisy chain, the devices who is nearby to the processor that have the highest priority. The method is also unique and simple. Disadvantage, as we add some additional features over there, adding bus master is difficult as increase the number of address line. As I mentioned, the address line will increase because each device will receive the connection in parallel. If one device fails, then the entire system will not stop. But in daisy chain, that happens. If one device fails, the whole network will stop. Third one is fixed priority or independent method. In this, each master has a separate pair of bus request and bus grant line. That is one of the basic difference between parallel arbitration or polling arbitration and fixed priority or independent arbitration. I will show you with the help of detailed diagram in the next slide. Here we have D1, D2 and D3, D4. In this method, bus arbitrator has a control lines. These control lines are connected as similar to the previous network, but the basic difference here these devices has a individual pair of bus request and bus grant. And so on. So what will be the main advantage? We don't wait for a bus request signal that connect in a parallel to all the devices that have dedicated connection, but they have a common data sharing path as in other devices and bus busy line. So there are some advantages or disadvantages of each method. Advantage, this method generates a faster response, as obvious, because these devices has a separate pair of bus request and bus grant signal. And disadvantage, because costing and networking will be complex, that's why control line will increase, cost and hardware cost and complexity will increase. Thank you. We will meet in our next presentation for next topic.